My name is Inigo Montoya. You killed my drawings. Prepare to thrive.
Well said.
Pretty much anything. I might get into talking about MBD, MBE, PMI. Those will be the main three acronyms that you'll be hearing. PMI, of course, is product manufacturing information, which is essentially the foundation of MBD. MBD is model-based definition. You're going to be seeing that especially Department of Defense and other OEMs are pushing and mandating the use of MBD to have us go into becoming model-based enterprises. So all of your MBs in this presentation are going to be model-based, and then essentially we want to go from model-based definition into creating model-based enterprises that are set up to thrive in today's world. In this conversion, in going from 2D drawings and having to recreate all of the information used to take your product from concept or design into reality, we're converting into creating an integrated digital environment. You're going to have a digital twin of your product, whatever it is. That is, you're going to have a digital copy of it, and your engineers are going to define and create the PMI, which is then going to, as you'll see in today's presentation, be reused several times, saving you lots and lots of time and money. As indicated by the graphic and the word bummock, if we don't know what bummock is, I didn't know it actually prior to this presentation some time ago, but the bummock is the underwater portion of an iceberg, which we probably through our lives have heard that the bulk of it is underwater and is unseen. And there are a lot of hidden costs in developing our products that are unseen. And MBD and this whole modern way of manufacturing products is going to eliminate a lot of those hidden costs. I just realized about a month ago when I got this Norelco shaver that my shaver is connected, that it has a accelerometer in it, and it has an app associated with it that will basically advise me on the cut pattern that I'm using on my face. It kind of blew me away. But what we're finding is that all of these products, down to something as simple as a shaver, are integrated into the web. There's data and there's all of these things. And what Siemens has done is they are taking these complexities and they've made software to help us handle those complexities, and not just handle them, but give the users of the Siemens portfolio an actual competitive advantage over others. How are they doing that? They're doing that by allowing us to create our comprehensive digital twin. Through that comprehensive digital twin and through the portfolio, we're creating an adaptable ecosystem for you. Essentially, we can build the software around your company, and it allows you to create your CAD models, to do your simulation, and to do all of the steps. And as you might hear down the road, we won't be talking about it much today, but through Mendix, we're able to integrate everything into your business software, into your CAD, into your CAM, into everything. You're going to find that through the Siemens ecosystem, you're able to integrate everything together, making it very easy and very rapid to go to market with your product. So here we're kind of seeing a little bit of the process in a MBD environment. So our designers create, for instance, here we've got a private jet. In the designs and the individual parts of that private jet, we're adding our PMI. And that product, as identified by that down arrow that you can see there, that would be our output to, whether it's to our suppliers, whether it be to our OEM that we are creating product for, or whether it be to a manufacturing shop that is going to create the different parts for us. long gone are going to be the days of needing to have several GD&T experts on staff. Included in the ecosystem and with MBD in NX is the PMI advisor. And I'm going to step back a minute and mention something very important. MBD is not just a Siemens thing. MBD is being driven by the Department of Defense, by the OEMs, by the automotive industry, and within the Siemens portfolio, we're able to import and use PMI and model-based definition from any system. And I think that's important to mention that, this is not a, well, yeah, I'll just leave it at saying that within the Siemens ecosystem, we can use and leverage everyone's PMI. So yes, and anyway, included with that is once we go into the step of the PMI advisor, what it's going to do is it's actually a digital GD&T expert, and you can quickly run an analysis, and it will tell you if there's a problem with your PMI, which is essentially like looking at what used to be a 2D drawing. And it's important to mention here that from the PMI, so just to take you kind of through the process, your engineers will add PMI to your models. That PMI will be checked by the PMI advisor, and then you can use that information in CAE for setting up whether it be a CFD analysis, whether it be an FEA analysis, whether it be a multi-physics analysis. And then two of my favorite tools that leverage MBD are NXVSA or stack-up analysis. So in the instance of this aircraft here, you've got a flap on the wing, or let's use the elevator. You've got an aerodynamic surface that is connected via links to some hydraulics and to a control system. And we'll say just for old-fashioned sake that there's cables. What VSA will do is it will look at the manufacturing tolerances of every single link between the pilot's hands to the yoke and all of the links that follow back to the flight control surface. And using the future control frames, using all of those tolerances, it will actually exercise your assembly and show you how much hysteresis, how much deviation there might be from the neutral position of that flight control surface to its extrema based on the tolerances. And so gone are the days. I mean, I worked for a company that had an Excel spreadsheet back in 2011 in which every single tolerance was put into this spreadsheet, and it was kind of like a matrix, and you would have to highlight column A and which component you want to start from and go all the way down to identify the how much stack up and how much deviation you may have. And then, of course, my real favorite, having been an application engineer for a CMM company, my favorite application where the PMI is used and is leveraged for free is going to be in programming a CMM. And you're going to see part of that in a little demo video that we have of how quickly you can go from just your CAD model to having a complete CMM program. All right, so here what we're seeing is a 3D PDF from NX with the TDP bundle, the technical data package. You're essentially going from your CAD model and your CAD views into what you're seeing on the right-hand side here. This is actually an image that I took out of Adobe PDF, or out of Adobe Acrobat, of a 3D PDF that NX outputs. And you can see on this bottom row here, hopefully you guys can see my mouse arrow, but you can see that in NX, we're going to organize your PMI into views, similar to how you would have had them in on a 2D drawing. You'll have different views with the information that is needed. Like here you see MBD columns, MBD front, MBD general, and you can name those any which way you want. but all of your information is in these views. And from this PDF, you just hit the print button. You select either the individual views you want to output or all of the views. And for instance, if I'm on the shop floor in a machine shop, and I want to, instead of looking at it on screen, I want to output it to a piece of paper so that I can, highlight it or make some check marks or whatever I may want to do, you can quickly print it. It's important to mention, here, you can't see it, but in this window, this is actually a 3D PDF. And Chris, remind me at the end, I have prepared copies of this 3D PDF that I think we should really share with everyone, so everyone can play with it and can see how essentially you've got a 3D model. You can measure it, you can output the views. And for you guys that may be in the naval industry or where your vehicles or product is huge, this zoom to PMI button is worth its weight in gold. I was working on an aircraft project once, and I had to literally dig around to find datum A, datum B, datum C. Those days are gone. Just click the zoom to PMI, go into your list, and select the datum, and it'll quickly zoom to exactly where that datum is, or exactly where that dimension is, or exactly where that feature control frame is. And it will highlight it in red, as you can kind of see here. From there, you can zoom out and quickly identify where it is. Okay, so here, what I'm showing you is what might happen creating this propeller. We receive, and I'm going to pretend that I'm a machine shop and that I'm creating this propeller for some shipbuilder or OEM. And essentially, I've received the CAD file with PMI, whether from an X or from, the PMI is essentially CAD neutral. And so we're able to bring it in. But in this case, we've got our CAD file, and through a application called Staged Modeling, I can take somebody, and with a half a day's training, I can get a process engineer with no NX training to go from the finished product, as we're seeing, in the CAD with PMI image here, and I can get them to quickly remove features so as to wind up with the as cast propeller or as forged propeller, and create notes and manufacturing processes, in either direction, either starting with the finished product, going back to cast, or cast and going back. And as you're going to see in every function in NX that leverages your PMI, there's going to be a button called Reuse PMI, which essentially is just leveraging the work that the OEM or the designer has put in without having to recopy it and recreate it. And that happens in staged models. That will happen in manufacturing, whether we're doing fixturing, tooling, CNC programming, simulation. We can use all of that information down into our work instructions. And my pride and joy, NXDMM, where literally in 15, 20 seconds, you're automatically creating a CNC or DCC, if you're a CMM person, a program with the probe angles, your A and B angles automatically created based on the PMI and the features associated with the PMI. So yes, so perfect transition. Here's our Reuse PMI button, and you're going to see that everywhere throughout the ecosystem. So here I'm showing you the staged models functionality that we're just talking about. And the first thing that would happen when I start from scratch is I'm going to say link geometry, and I'm going to essentially inherit not only the CAD model, but then I can choose which PMI I want to use and which is necessary for those features. And as I go through the stages, in this case, because I was delivered a finished propeller model, I went through and selected the PMI that I needed, and then I go through the stages of creating the different operations. So I go from the finished to, let's say, op 30 to op 20 and to op 10, which might be just qualifying the face of the propeller. And as you're going to see, like I said, the reuse PMI is the golden button, which allows us to reuse everything. In the case of the CMM, again, the button happens to be called Link to PMI. And essentially what you're doing here is you are linking your CMM program to the different dimensions and tolerances. And so you would hit that Link PMI button. And as you're going to see, and I'll kind of introduce you a little bit to what you're going to be seeing in this demo video that I'm going to start here. But as I mentioned earlier on, you're going to organize your PMI in views, which many of you may have seen and are familiar with. But we organize them however makes sense for you, whether it can be in front view, side view, detail view, and all of those things. And so then similarly, whether we are doing a VSA, a stack-up analysis, or whether we're creating a CMM program, or whether we're creating a CNC program, if I'm looking at the high pressure side of a propeller, I would select that view and I would probably be grabbing dimensions from there. So as you're going to see here, and I'll start this video and I'll talk us through it. I'm going to go ahead and open this propeller part. And in the beginning here, you're going to see we've got all of our PMI, and this view here in particular happens to have everything. But as I scroll through here, I'm just kind of showing you that the PMI is organized by views. And well, your PMI, you saw it first. You can list and show it all by PMI. And then here, actually, we're going through and I'm showing you the different views and how you might have different dimensions shown and isolated. Then at this step, we're going to go ahead and we're going to create a new CMM program. And similarly, I'm going to show you how you can go and select the views. Maybe there's so many dimensions in your product that you don't want to look at all of the PMI. And so here, now that we've created this new CMM program, and in the process, I chose which CMM I wanted to use. And as you'll see, we're going to also simulate the machine so we can make sure that we don't have any crashes. Usually 60–70% of the cost of a CMM is in the head of the machine with our, whether you have a Renishaw probe or whichever brand probe. And so we want to make sure that there's no collision. So here I'm filtering the dimensions that I want to bring from which views in the product. So even if I'm the CMM programmer and I'm not familiar with the product itself, via company standards, I'll be able to see and select the views that I want to use, depending on the orientation of my part. And I'm going ahead here and I'm selecting to display them as well as use them.
That's a country.
Okay, so now we've got the information showing that we want. And by hitting the link to PMI and create paths, and I said yes, you will see here that in 15–20 seconds, we have actually created not only the CMM program, but we've transferred all of the tolerances into the report. So long gone are the days of the CMM programmer having to look at the drawing and add the tolerances into the report. All of that stuff just happened automatically in that amount of time. And let me rewind real quick for a moment. Yeah, so here I'm selecting the program and I hit the generate button. I mean, it happened so quickly that we essentially missed it. But right here, I right click and I said to generate and now simulate. And so at this point, what you're going to see is I want to make sure, it was for the sake of the video, but I made sure that the propeller was oriented in a way that might collide. And just to show that, we're going to detect a collision and just how quickly we can go from this program where the propeller is oriented in this direction. I'm going to rotate it, we got 5 blades. So I'm going to rotate it, I think, 36 degrees and regenerate the program. And so what you're seeing is in the time of this video, not only did we add all of the dimensions, we created the report adding all the tolerances, but we also programmed the CMM with the A and B probe angles and simulated it. Realized that we have a collision, and then rotated the part, which of course means we have to regenerate the program, as you just saw in that last click. I've regenerated the program with the part oriented in a different orientation, and we'll go through and run it again. And of course, if you are a metrology person, you know that my AB angles had to change again once I reoriented the part because my surface normals changed. So in that time, it also reoriented the AB probe angles. In this case, I want to get the CMM closer to the root. I want to check points, so let's say a surface tolerance across that particular blade. And so what I did is I went ahead and I edited my my A angle to rotate the probe so that I could get closer to the hub without that collision. And you can see we made it through that portion of the inspection. And, we can carry on to measure all of the holes and everything. And done. So essentially, what you just saw is the speed in which, I think this video is like 3 minutes or so. 4 minutes and change. So in under 4 minutes, we created our CMM program. We created and populated our report. We redid the program and reoriented the part, leveraging the power of MBD to do all of that. And that is why in all of these industries, you're going to find that whether you are the OEM and you're going to be supplying your product information using PMI and MBD, or if you're a supplier or a manufacturer or a sub-design group that is helping to put things together, you're going to find that, in the marine industry, in aerospace and defense, in automotive and transportation, in all of these different businesses, you're going to find that the future is in leveraging MBD to increase your productivity. So what you've seen in this, quick demonstration is that your engineering team, they're going to create this PMI, this model-based definition and product data. And instead of them having to create a drawing, the machine shop having to look at that drawing, analyze it, decide what tools to use, your engineering team that is checking to make sure that all of your assemblies are going to go together and there's not going to be any loose fits, your quality people, they are going to take that original data and they're going to reuse it. You don't have to have staff continuously converting from a 2D drawing into the next phase, whether it be CMM, whether it be, stack up analysis, all these things. They're all going to be leveraging information that was created at the top end, at the front, and saving you a ton of time in developing your product.
Real quick, who are we at Spatial Integrated Systems? We've been around for 25 plus years. We were established back in 1997. Our headquarters is in Virginia. All of our operations and resources are based within the U.S. We are also proud to be a top expert Siemens software partner for 7+ years running, which gives us the ability, like a Savan, where he has the ability to convey and provide assessments and discoveries around MBD, NX, CAM, CAD, data management, simulation. So we've got a lot of technical expertise on hand to help you from cradle to grave as it relates to different workflows and operations that you're executing from your business perspective. Also government, we are tied nicely as the sole proprietor of the software government contracts, where we've saved multiple companies between 50 and 70% of their procurement time because of our internal knowledge and expertise from a government standpoint. And then also we've really elevated ourselves from a model-based accelerator standpoint when it comes to helping you better your methodology around MBD or CAM or CAD or data management as an example. So again, we're here to help from cradle to grave on either the beginning, the end, or anywhere in the middle as it relates to the different products and different operations that you're servicing for your clients. So I'll let Savan jump. We'll kind of tag team this, Savan, but what's next? You want to just quickly highlight a recommended health check assessment when it comes to model-based definition?
Yeah. So yeah, as the slide says, what's next? Well, if you're interested in becoming a model-based enterprise and increasing your productivity, saving time, we can help you with a health check assessment. Essentially, we can, whether virtually or on site, come to your facility and look at the processes that you're using and look at how your data flows in and through your company, and whether it's through digital threads, help you get on board and figure out which products and how to integrate those products into your business, and how to take advantage of these new technical possibilities. And there's lots of different ways that we can help you. If you're an existing customer, there's things that we can do. If you're new and you want to get in through, a Siemens Supplier program or a startup program, there are lots of ways that we can help you get on board. I mean, I'm more on the technical side, and I can help you figure out what you need to do, and then our guys like Chris and Chet and Greg and everyone can kind of help you as far as identifying whether you qualify for an A&D discount or a supplier, or one of the tons of ways that we can help you get started on your journey. I think we actually went through this fairly efficiently.
We did.
And so if there are any questions, I think we can have a Q&A session right now, but I would really encourage you, after this call, to take some time and think about things. I'm going to go ahead and send Chris that 3D PDF so that we can share it with everyone, so you can kind of, work in there and see what you think as far as rotating the model. I think there's actually, and I didn't mention this, but the 3D PDF is kind of like a zip file. In this 3D PDF, you can add text notes, you can add a CAD model. Essentially, you're sending one file, and that file can have everything that your OEM or your machine shop or anyone could possibly need to manufacture your product. I do encourage you to open the PDF and take a look at it. The 3D PDF can contain step files, CSV files, or others, all within the PDF. Yes, absolutely. Yes, essentially, when you in NX go to create a 3D PDF, you're provided with a window with 3 tabs. In the first tab, you determine the template that you want to use to create your 3D PDF. In that window, you can select whether you want security, so we can password protect the 3D PDF so that, only people with the password can have access to it. In the middle tab, I believe, is where we select the attachments. And so at that point, in that window, you would select if you want to add a step file, if you want to add a CSV file, if you want to add a PO. You want to send one file to your customer or to your supplier. That's all you need is the 3D PDF. You can attach the PO to it. You can attach anything you want into a 3D PDF. Absolutely.